Hello children and welcome all of you to the class of mathematics. We are discussing chapter number 15 probability and we have solved few examples from exercise 15.1. Today we are going to solve few more from the same exercise. So here is question number 12 from exercise 15.1. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7 and 8. See the given figure. Yeah children, I will be showing you the figure. And these are equally likely outcomes. What is the probability that it will point at number 8? So a spinning wheel, this is what is given to you. There are 8 numbers there and the pointer will point at every number equally because we are given that it is equally likely outcome. So let's write the data first. Total numbers which are given to us is 8. We have been asked what is the probability that the pointer will point at number 8. So the pointer will point at number 8 only one time since it is equally likely outcome. So number of times we can get 8 is equal to 1. Now we can use our simple formula of finding the probability. So probability of getting number 8 is equal to number of times we can get 8 divided by total numbers there on the spinning wheel. So number of times we can get 8 is only one time. So our answer is 1 upon 8. Alright. There is second part of the sum. You are asked what is the probability that the pointer will point at an odd number. So our data is total numbers which are there on the spinning wheel is 8 and odd numbers that can be our outcomes are 1, 3, 5 and 7. So on the spinning wheel you can make out that all odd numbers are 1, 3, 5 and 7 and these are 4 odd numbers. So probability of getting an odd number is equal to total number of odd numbers which are there on the wheel divided by numbers which are present on the wheel. So odd numbers are 4, total numbers on the wheel are 8. So our probability is 4 upon 8. We can reduce it to lower term and your answer is 1 upon 2. So probability of getting an odd number is equal to 1 by 2. Keep one thing in mind children, the answer for the probability you have to leave in fraction. There is no need for you to convert this into decimal point. Now there are two more parts of this sum, question number 3 and question number 4, but this is for your homework. You all will do it on your own because I am sure now this is very easy and you all will be able to do it nicely. So moving ahead, the next sum, this is question number 13. A die is thrown once. Find the probability of getting a prime number. Now you all are aware that when the die is thrown, we have got 6 possible answers. So the total number of outcomes that can occur after throwing a die are 1, 2, 3, 4, 5 and 6. So you can say that number of possible outcomes of a die is equal to 6. We are asked what is the possibility of getting a prime number. So let's first understand what is the meaning of prime number. So these are the numbers wherein they have only 2 factors, that is the number itself and 1. So from our possible outcomes, that is 1, 2, 3, 4, 5, 6, the prime numbers are 2, 3 and 5. Keep one thing in mind that 1 is neither prime nor composite number. 2 is the only prime number which is even. So these 2 things please always keep in mind. Now coming back to our sum, that we have to find the probability of getting a prime number, and in our data we have the prime numbers as 2, 3 and 5. So these are 3 prime numbers. We will write like that. Total prime numbers on the die are 3. So probability of getting a prime number is equal to number of outcomes where prime numbers comes and divided by total number of outcomes. So number of outcomes where prime number comes is 3, which we have already calculated, and total numbers which are there on the die are 6. So 3 upon 6, reduce it to lower term, and the answer is 1 upon 2. Alright, then there is second part of this sum. Let's see that. This is question number 13, and its second part is a die is thrown once. We have to find the probability of getting a number which lie between 2 and 6. Alright, so we know number of possible outcomes are 6, and the numbers lying between 2 and 6 are 3, 4 and 5. Alright, so total numbers lying between 2 and 6 are 3. Okay, which are these 3 numbers? These are 3, 4 and 5. So we'll write our formula then. Probability of getting a number lying between 2 and 6 is equal to number of outcomes where there is a number lying between 2 and 6 divided by total number of outcomes. So number of outcomes, how many outcomes we have? We have 3 outcomes. Those 3 outcomes are 3, 4 and 5. So 3 outcomes are there. So 3 upon 6, and 3 upon 6 is equal to 1 by 2 after reducing it to lower term. Alright, then there is third part of the sum, that you have to find a probability of getting an odd number when the die is thrown, and this I'm sure you will be able to do it. Odd numbers will be 1, 3 and 5, and finding its probability is not difficult. So this is for your homework. Then the next type of the sums are based on playing cards. So before we go to the next sum, I want all of you to have a look at this. There are 52 playing cards. Out of these 52 playing cards, 26 cards are black and 26 are red. In the black cards, we have 13 spade, 13 club, and in the red cards, 26 red cards, we have 13 diamond cards and 13 hearts. Alright, now in this 13 spade cards, we have one ace. This is called as ace card of spade. This is ace card of club, ace of diamond, and ace of heart. So out of 13, one is ace card, and along with ace card, we have some face cards also. So let's have a look at that. So the face cards of spade are king, queen and jack. Face card of club, again king, queen and jack. Face card of diamond, again king, queen and jack. And face card of hearts is again king, queen and jack. So if you count total face card of all the 4 types, these are 12. So in a pack of 52 playing cards, we have 12 face cards. So with this note and with this information, our next sum is based on this particular thing only. So let's see the sum. So the sum is, this is question number 14. One card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a king of red color. Now see children, you can see the picture flashing there on the screen. We have 4 kings there in a pack of 52 cards. We have been asked probability of getting a king which is red in color. So you can just see there we have 2 kings red in color, diamond and heart. So let's find the probability. Total number of cards 52. Then total number of kings of red color is equal to 2. So probability of getting a king of red color is equal to number of king cards of red color upon total number of cards. So we have 2 cards of king which are red in color. So 2 upon 52. You can reduce it to lower term and the answer is 1 upon 26. Alright. So this type of sums are very important in your exam. One sum based on the deck of 52 cards is for sure there in the exam. Alright. Then this is the second part of the sum, that a card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a face card. Now just now I told you how many face cards are there in a pack of 52 cards. So the image is flashing there on the screen. We have total number of cards as 52. Now which are the face cards we have? We have 4 kings, we have 4 queen, we have 4 jacks. So total face cards are 12 because each type has 4 cards. Alright. Then find the probability of getting a face card. So probability of getting a face card is equal to number of face cards upon total number of cards. Now we have number of face cards as 12, total number of cards as 52. So 12 upon 52, we can reduce it to lower term and the answer is 3 upon 13. Alright, it's very easy to solve the sum, children. Only important thing is you should understand the sum and you should be able to guess as to when it is asked for the face card, how many. Quickly you should be able to count from a pack of 52 cards. Yeah. Then this is for your homework. Find the probability of getting a red face card. Now all the face cards are flashing there on the screen. When we say red face card, look at this. How many red face cards are there? So there are 6 red face cards. So once you count that as number 6, you can find the probability. The second part is find the probability of getting a jack of hearts. So in the third row, that's the row of all the jacks of 4 types. Out of that you have to find the jack of heart. So jack of heart is here, only 1 card, and based on this information you can find the probability. So this is what you have to do. These 2 sums are for your homework. I want all of you to solve it and keep it ready to revise for the semester exam which is coming up now. Then moving to the next sum. This is 1 card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a spade card. This is the 5th part of question number 14. Okay. First 2 we have solved. Then 3 and 4 is for your homework and this is the 5th part. Now see, they have not specified anything. They have not specified as ace card, face card or whatever. What they said, what is the probability of getting a spade card? So how many spade cards do we have? We have total number of 13 spade cards. Alright. So total number of spade cards is equal to 13 and we have total number of cards as 52. Then probability of getting a spade card is equal to number of spade cards upon total number of cards. We have 13 spade cards. We have total number of cards as 52. So 13 upon 52 is the probability. You can reduce it to lower term. 1 upon 4 is the probability of getting a spade card. So you have to be very careful while reading the sum what they have asked. It's just a card or it is a face card or they're asking for the ace card or numbers. Read the sum carefully. Alright. The next part of the sum is find the probability of getting a queen of diamonds. So each type has only 1 queen. I hope you'll be able to solve this. This is also for your homework. Alright. Now moving to another interesting sum. This is question number 15. 5 cards, the 10, Jack, Queen, King and Ace of Diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is Queen? Look at this. According to the data, we have been given 5 cards. So we'll write total number of cards as 5. What is the probability that the card is Queen? So number of cards that are Queen in the given data is only 1. So finding the probability is very simple. So probability of getting a Queen is equal to number of cards that are Queen upon total number of cards. So number of cards that are Queen is only 1 card. So 1 upon 5 is the probability of getting a Queen. Alright. Then the next part of the same sum. If the Queen is drawn and put aside, what is the probability that the second card picked up is an Ace card and a Queen? Read the sum. If the Queen is drawn and put aside, that means out of the 5 cards, the Queen is drawn and kept aside. Now how many cards do you have now? So total number of cards which are left with us is equal to 4. So what is our sample space? Sample space has 4 points now. Then what is the probability that the second card picked up is an Ace card? So just find out that. Now number of cards that are Ace in the remaining cards, that is equal to 1. So we'll use our formula. So probability of getting an Ace card is equal to number of cards that are Ace upon total number of cards, and that is 1 upon 4. Yeah. So 1 upon 4 is the probability of getting an Ace card. Next you are asked, what is the probability that the card picked up is a Queen? Now see, Queen is already taken from the 5 cards and kept aside. Then what is the probability of getting a Queen? 0. No probability, because the card is not there only. So probability of getting a Queen card is 0. Alright, so there is no data for that. Directly you can write probability of getting a Queen is equal to 0. Alright children. So with this sum, we will stop for today, and the remaining sums we will solve in the next video lesson. Till then, bye and take care, and don't forget to do the sums which are given for homework. Thank you.